Hi everyone, in this video I want to talk about factoring trinomials with a leading coefficient of 1. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. What is the very first memory you can remember from when you were a very small child? Alright, so factoring trinomials falls under quadratics. And typically in an Algebra I class, you would learn quadratics for the first time. It's usually reinforced in Algebra II, but we'll call it an Algebra I concept. And specifically, we are trying to go backwards from the FOIL process. So first, outer, inner, last, that's multiplying two binomials. So if you were asked to just factor something like this that has, in this first one, a k squared term, a k term, and then a constant, or just a regular number, you can't take anything out of all three terms. So then you think, okay, how could I break this trinomial, three terms, into something smaller? And if you think back to the FOIL process, that is, if you had x plus 3 and x plus 2, the FOIL process says x squared plus 2x plus 3x plus 6 would be our process, 5x 6. So then we realize that to get this trinomial, we are adding the 3 and the 2 to get the middle term. And we are multiplying the 3 and the 2 to get the third term. So if I'm trying to go backwards, you can see that I'm multiplying the 3 and the 2 to get the 6. I'm adding the 3 and the 2 to get the 5x. So that means that we need to think about what multiplies to the 4 and adds to the negative 5. Okay. So sometimes you'll see teachers introduce this concept with this X diagram, and they'll say, put a negative 5 there and a 4 there, and think about what's going to add to this number and multiply to this number. What's always easiest is thinking about all of the factors of that last number, the third. So if I'm trying to think about what two numbers go here, what adds to negative 5 and multiplies to 4, I would think, well, what are all of the factors of 4? I have 1 and 4, and I have 2 and 2. Okay. So that means that I can play around with 1 and 4 and 2 and 2 to get a negative 5 and a positive 4. So I'm noticing that 1 and 4 add up to 5, but how could I possibly get them to add to a negative 5 and multiply to a positive 4? Well, if I change the sign on both of them, if I make them both negative, that would multiply to the positive, but then add to the negative. So that means that the answer here must be k and k, we know that, but then minus 1 and then minus 4 get plugged in to the parts for each binomial. So I could write my answer as that, or I could do k minus 4 and then k minus 1. But I can't change those subtraction symbols to be adding symbols. I cannot add them. They can't be plus signs in order to get that negative 5 in the middle. So either of those answers are fine. The reason being is, commutative property tells you that, say, 2 times 3 is the same thing as 3 times 2. So either of those answers work. Okay, now let's go to the second one. Do the same thing. So I'm going to put my adding number up here, my multiplying number here, and start messing around with the factors of 27. So we have 1 and 27, and then 3 and 9, and that's it. Sometimes you'll have a number that has a bunch of factors and you have to go through them, but this one is fairly easy. I can tell 3 is 6 units away from 9. So if 1 and 27, definitely, that's not going to be our pair that we're working with here. We want to figure out what can add to -6 and multiply to -27. So if I have a negative that they need to multiply to, I know that they're going to be opposite signs. One will be positive and one will be negative. They have to add a -6, so that tells me the 9 must be negative. So you have -9 plus 3 is -6, and -9 times 3 is -27. So we have m minus 9 plus 3, final answer. Or I could write that as m plus 3, m minus 9. But I do want to write a note that says it cannot be like m plus 9 and then m minus 3, which is a common error, because those two numbers would add to a +6 here instead of a -6. All right, let's try some practice problems. Here they are. Why don't you go ahead and pause the video if you would like to take some time before you see the answers. All right, answers are 3 and 6, and then -8 and 10 should have been the numbers that you need for those. All right, I have a quote to finish us off here. If you want to lift yourself up, lift someone else up. I love this. I think, if we're ever in a bad mood, it's probably the most effective strategy to just go help somebody else. It really does make you yourself feel great. All right, I hope this video helped you in some way. If you have a good answer to the fun question, I'd love to see it in the comments. And I would love if you would click subscribe if you would like to keep up with more videos. Thank you.